Late November 2025 has arrived, and with it, a distinct shift in the atmosphere. Across neighborhoods and city parks, the signs of early winter are unmistakable: bare trees, frosted lawns, and a quiet stillness that hints at the season ahead. A sharp early winter chill has settled across much of the U.S., catching many off guard. People are bundling up in heavy coats, their breath visible in the crisp morning air, while cars and sidewalks glisten with a layer of frost that lingers well into the day. This isn't just a fleeting cold snap. Instead, powerful Arctic outbreaks are sweeping down from the north, hinting at a much larger and more persistent pattern. The icy wind that whips across open fields and snow-covered landscapes is a sign of something brewing in the upper atmosphere. Atmospheric science is pointing to a colder, snowier winter ahead. This isn't just wishful thinking or speculation. Meteorologists are seeing clear signals in the data. Snow is already falling in places that typically remain dry until later in the season, and cities are bracing for what could be a long, challenging winter. The main drivers behind this forecast? Early, intense Arctic air masses are surging southward, and there are growing signs of a sudden stratospheric warming event, or SSW, developing high above the Earth's surface. Scientists working in the field are closely monitoring these changes, knowing they can have far-reaching impacts. When a sudden stratospheric warming occurs, it can dramatically shift weather patterns across the entire northern hemisphere. The polar vortex, a swirling mass of cold air, can weaken and split, sending frigid air plunging much farther south than usual. This phenomenon has the potential to reshape the winter for millions. These early signals are setting the stage for the next few months. Communities are already preparing. Snow plows are out earlier than usual, and families are winterizing their homes, stocking up on supplies and bracing for what could be a series of significant winter storms. Research shows that expansive Siberian snow cover in autumn can disrupt the polar vortex, sending frigid air southward into North America and Europe. This year, Siberia has seen record snow accumulation, which is a key ingredient in the recipe for a colder, more volatile winter. This winter forecast is built on a web of interconnected global patterns, not just one cold front or isolated event. The jet stream, polar vortex, and snow cover across continents all interact, creating a complex puzzle that scientists are working hard to piece together. The early November cold is more than just a brief chill. It's a symptom of a larger atmospheric state that's primed for significant winter events. Sub-zero temperatures, early snowfalls, and persistent frost are all signs that the atmosphere is gearing up for a memorable season. As we move into December and January, the impact of a potential sudden stratospheric warming could become clear. If the polar vortex weakens, we could see prolonged cold spells, heavy snow, and dramatic shifts in weather that affect everything from travel to energy demand. The pieces are falling into place for a winter that could be remembered for years to come. Whether it's the joy of children playing in fresh snow or the challenge of navigating heavy storms, the 2025-26 season is shaping up to be one for the record books, full of surprises, challenges, and moments of wonder. To truly predict what kind of winter lies ahead, we have to look far above our heads, beyond the weather we see every day. The secret is hidden in the stratosphere, a layer of the atmosphere that sits high above the clouds, where the air is thin and cold. Here, powerful forces are at work, shaping the weather patterns that will eventually reach us on the ground. At the heart of this story is the polar vortex, a massive ring of winds that spins tightly above the North Pole. This swirling system acts like a barrier, trapping the coldest air over the Arctic and keeping it locked away from the rest of the world. When the polar vortex is strong and stable, it keeps the frigid Arctic air contained, meaning winters in North America, Europe, and Asia tend to be milder. The cold stays up north, and the southern regions are spared from the harshest winter blasts. But sometimes, a dramatic event called a sudden stratospheric warming, or SSW, occurs. In just a few days, temperatures in the stratosphere can rise by 50 degrees Fahrenheit or more. This rapid heating disrupts the polar vortex, throwing it off balance. When this happens, the once strong vortex can weaken, stretch, or even split into two smaller vortices. This breakdown allows the cold Arctic air to escape its polar prison and surge southward, reaching areas that are usually much warmer. The jet stream, which acts like a river of air guiding weather systems, also becomes more wavy and erratic. These big dips in the jet stream open the door for frigid Arctic air to spill into the US, Europe, and Asia, bringing sudden cold snaps and heavy snowfalls. Think of an SSW as someone bumping a spinning top. The top wobbles, loses its balance, and chaos follows. In the atmosphere, this chaos means unpredictable and extreme winter weather. The effects of an SSW don't reach us right away. It usually takes about 2 to 3 weeks for the changes in the stratosphere to work their way down to the surface, giving meteorologists a valuable window to forecast what's coming. If we spot an SSW event in late November or December, it's a strong signal that a cold, snowy period is likely on the way. This early warning can help cities prepare for winter storms and help people get ready for a chillier season. That's why tracking the polar vortex and sudden stratospheric warming is one of our best long-range forecasting tools. It gives us a rare glimpse into the future of winter weather. Right now, the atmosphere is already showing signs of this big move. Meteorologists are watching closely, ready to see if the stratosphere will tip the scales and set the stage for a dramatic winter ahead. The current cold gripping the nation is more than an early chill. It's a major atmospheric clue. This isn't just a cold front, it's a deep Arctic intrusion, with temperatures rivaling January averages. The air's origin and persistence point to a weakened polar vortex and a wavy jet stream. This early cold primes the ground, building snowpack and reinforcing future outbreaks. A frozen landscape helps cold air maintain its intensity as it moves south. This feedback loop sets up a persistently cold winter pattern. Real-world observations now match our seasonal models, boosting forecast confidence. The extensive Siberian snow cover in October suggested this was coming. One cold snap doesn't make a winter, but this event is a strong signal for a colder, stormier season. A sudden stratospheric warming starts a chain reaction high above us. The SSW weakens or splits the polar vortex, like cracks forming in a dam holding back cold air. This disruption slowly works its way down to the troposphere, where our weather happens. The tropospheric vortex stretches and wobbles, sometimes splitting into multiple lobes. Blocking patterns develop, large high-pressure areas that divert the jet stream. The jet stream becomes wavy, creating deep troughs that funnel Arctic air south. These troughs are the pathways for prolonged cold outbreaks. An event that starts 20 miles up can lead to Arctic air in your city. The SSW weakens the vortex, blocks form, and cold air is steered south. This sequence can turn an ordinary winter into a memorable one. It's the complete atmospheric domino effect. Blocking patterns are the secret to a lasting winter. Without them, cold air comes and goes quickly. A blocking high, like the Greenland Block, disrupts the usual west to east flow, forcing the jet stream south. This creates a conveyor belt, funneling Arctic air into the US for days or weeks. These blocks also set the stage for major snowstorms, as cold air meets moist Atlantic or Gulf air. Storms can intensify and linger, impacting wide areas. A potential SSW this winter increases the odds of these persistent blocks. Monitoring the North Atlantic Oscillation, NAO, is key. A negative NAO signals a Greenland block and higher winter weather chances. The right block can make all the difference. Arctic outbreaks are the dramatic end result of a complex series of atmospheric shifts that begin far to the north. These events are not just random cold snaps, they are the culmination of weeks, sometimes months, of subtle changes in the upper atmosphere, all converging to unleash a surge of frigid air. In the polar regions, where the sun barely rises during winter, the land becomes a vast, frozen reservoir. Here, dense frigid air accumulates, growing colder and heavier with each passing day, waiting for the right conditions to move south. Normally, the polar vortex, a powerful ring of winds high above the Arctic, acts like a barrier, keeping this icy air locked in place. But when the vortex weakens or becomes unstable, cracks form in this barrier, and the cold air escapes, spilling southward. Guided by a wavy, meandering jet stream, this Arctic air plunges south, hugging the ground as it travels. As it moves, it can cause temperatures to drop rapidly, sometimes by dozens of degrees in just hours, transforming mild weather into a deep freeze. The intensity of the cold depends on both the source and the journey. If the air travels over snow-covered land, it stays bitterly cold. But, if it passes over open water, like the Great Lakes, it can pick up warmth and moisture, sometimes fueling heavy snowstorms instead. Sea ice and deep snow cover in northern Canada are especially important. They help preserve the cold, allowing true Arctic blasts to reach farther south and last longer, making these regions the engine room for winter's most intense cold waves. How long the cold lingers depends on the atmospheric blocking patterns. When these blocks are strong, they can lock the cold in place for days or even weeks, leading to extended periods of frigid weather. A persistent block means not just a quick chill, but a true cold wave. One that can disrupt daily life, freeze pipes, and challenge even the hardiest residents. This remarkable journey, from the remote Arctic tundra to the familiar setting of your own backyard, explains why this winter could feel much colder and more intense than what we've experienced in recent years. With all these elements in place, the stage is set for a winter season that could be both memorable and challenging, as Arctic air makes its presence felt across the continent. Forecasters are seeing strong signals for a classic cold winter, especially in the central and eastern U.S. Early Siberian snow cover, and a likely SSW point to a weaker polar vortex and increased risk of major cold outbreaks. Experts like Tom Niziol highlight the importance of high-latitude blocking for big snowstorms. Many are watching for a persistent Greenland Block, which could lock in cold and stormy weather for January and February. While some models weigh other factors like ENSO, the stratospheric signal is dominant this year. The consensus, the risk of a high-impact winter is elevated. Industries from energy to transportation are being advised to prepare. It's time for heightened alert and close monitoring. Early atmospheric signals have real-world impacts. For the public, a colder, snowier forecast is a call to prepare. Insulate homes, service heating, and stock emergency kits. Municipalities use these signals to plan, stock road salt, and ready plows. Early action is more effective and less costly than reacting to a crisis. The energy sector can manage supplies, and transportation can brace for disruptions. Even retail is affected, from winter gear to foot traffic. Monitoring triggers like Siberian snow and SSW events is about managing risk. The forecast isn't a guarantee, but it's a clear warning. This winter, the atmospheric smoke alarm is sounding. Preparation is key. As winter unfolds, watch for key developments. The evolution of the SSW is critical. A vortex split in December means higher odds of major cold in January. Track blocking patterns, especially over Greenland. A negative NAO signals a Greenland block and sustained cold. Watch the storm track. Nor'easters along the east coast are likely in this setup. The frequency and path of storms will reflect the larger atmospheric pattern. Don't be fooled by brief thaws. Persistent cold is what defines the season. The main drivers suggest a pattern that reloads with renewed cold and snow. Stay prepared and follow reliable weather sources. This winter could be one for the books. The stage is set for a dynamic, impactful season.